Hello guys, welcome back to my channel Code by Vansh, and today we are going to solve the question maximum width of binary tree. So let's begin. So in this question what we have given a root of a binary tree, return the maximum width of the given tree. The maximum width of the tree is the maximum width along all levels. The width of one level is defined as the length between the end node and the left rightmost non-null nodes, where the null nodes between the end node that would be present in the complete binary tree extended down to that level would also count onto the length calculation. Okay, so here you can see in the example, so in this example, as you can see, this is the full representation of this diagram. So if you can see, I have made one has a left node and a right node. Then 3 has a left node, and then as 3 don't have any right node here, that's why I added a null node here in the 3 node. Same with second, and so on. And after this you can see that the maximum width among all the levels, if this is a level, this is a level, this is a level, you can see that you can see here the maximum width is 2. Here you can see it is 4, right? Between here it is between 3 and 2. Here it is between 5 and 9. Here it is between 6 and 7. So you can see that the maximum length is between 6 and 7. And what is the length? 1, 1, 2, 3, 4, 5, 6, 7. So this is 7, and this is the most or the maximum length we can encounter. So in this question, if we have to solve this question, we have to think it like if this is an array, and you can see the binary representation in an array is always like there will be a root node, then there will be a left node, and there will be a right node, right? This is a root node, this is a root node, this is a left node, and then this is a right node. So in order to solve this question, what we will do, as we can see that we are moving in a level based traversal, so we got a thinking like we have an intuition of level based traversal, and we can see that we can use BFS. Okay, so this is the first thing we can use is BFS. Second, and we know that in BFS we have to use a queue data structure, right? So this is a thing we have to keep in mind. Second, we have to uh, we have to see that whenever we are adding, like if this is a node and this is the left node and this is the right node, so we always have to see that if we are adding, like if this is I and this is I plus 1, so if we have to add, like in the level based traversal, if this is a left node, then the level will be 2I plus 1 in the array representation, because we can see that always the left node is behind the right node. Here you can see first there is root node, then there is a left node, and then there is a right node. So that's why we can see that the left node always get a position of 2I plus 1, and the right always form a position of 2I plus 2. So these are the two intuitions we have to keep in mind. After this we can solve this question like a basic BFS part. So what we are doing, if this is a null, we are not doing anything, we are just returning 0 at the starting of the code. This is just like a base condition. After this what we are doing, we are making a queue data structure, and in the queue data structure we are adding our root node, and because we have to keep in mind the level also, that's why we are passing node as well as level value. And as you can see that root node is the first node, that's why it is a 0 0. So we set the answer, and this is just a normal normal BFS part. So here we are doing it until our queue is not empty. So while it is not empty, we are just taking the size of the queue, and while what we are doing, we are just checking the for the reference level, the first element in the reference level. That's why we are taking the second mini, then the last one and the first one. So as you can see that if this is my array and all these are nodes present in that, like if this is a root node, this is all the nodes present in the array. So these, like these four nodes can be present in the array, right? And in the array, this is my first node and this is my last node. So here in the code you can see there are two variables, which is a first one and the last one. So if it is a first one, then the condition would be, if the first one, then condition would be I is equal to 0, and if I is equal to the length minus 1, then it will be the last one. And at the end what we are going to return, last minus first plus 1. Obviously it is going to be the minimum distance. And if any of this node, like if any of this node, like take example of this, if this node left as well as right exists, then what we are going to do, then we are going to insert it into the array or pass a new recursion function such that 2i plus 1 for the left one and 2i plus 2 for the right one. As I told you that we do it like this only, like the left one has an index of 2i plus 1 and the right one has an index of 2i plus 2. So this is the thing. After this iteration, we will find out our maximum answer and we will return the maximum answer. So this is the coding part and the explanation part. I hope you like my explanation. Make sure to like, share and subscribe for more upcoming videos. Thank you for watching.